Okay, everybody listening here. Today what we shall see is when do we know a node voltage is the question that we are answering today. When do we know a node voltage? We already have answered when do we know a mesh current. When do we know that? See here, not here. This is a Supernode. Fine. Now, here in this type 2, if the current source is on the boundary of the circuit, we know the current source, current in that particular mesh, right? So if I know a mesh current in this mesh, I don't apply KVL, right? Similarly, if we come to node analysis, okay, if we come to node analysis here, if we know a node voltage, we don't apply KCL to that particular node. Why do we do node analysis? To find the node voltages. Node analysis is for finding the node voltages. Okay. Now what I'm saying is, when do we know the node voltage? Suppose, see here, you have a circuit like this. Fine. Now say there is another voltage source, or say there is current source, not a problem, anything. So when do we know a node voltage is what we are answering? See here, everybody, this is ground. Okay, how many nodes are there? See here, we have node 1, node 2 and node 3. So since we have 3 nodes, the voltages at those 3 nodes are V1, V2 and V3. Fine. Now you should see there is a voltage source between node 2 and ground. Get that point? There is a voltage source between node 2 and ground. So which means that suppose if this is 10 volts, okay, we can directly write our V2 is 10 volts. Understand that? So when do we know a node voltage? When there is a voltage source between the node and the ground, without any resistors in between. There should not be any resistor. If there is a resistor, again this is V2 is not 10 volts. And when we say V1, V2, V3, what they are actually see here, when we say V1, V2, V3, I'll just write down the same circuit. This is what we are writing. Fine, this is what we have. Okay, then we have the current source here. This is what is the circuit. So when I say V1 here, okay, when I say V1, suppose this is R1, R2, R3 and R4, say in general. Okay, so if I say V1 here, it means to say that there is a drop V1 across R1 is the meaning of it. Okay, so if you have V1 here, means this is what is the meaning of it. You have the drop between node 1 and ground. If this is ground point, this is also a ground point, because it's the same line which is extended. Everybody understand that point? Similarly, if I mark V3 here, it means to say that there is a drop V3 across R4. So if I say this is V2 and if I say this is 10 volts, so 10 volts is what is your V2. Everybody okay with this? Okay. When do we know a node voltage is what, or when do we know, or how do we come to know that we know a node voltage is what we are answering. So everybody, if you understand this point, you can understand any problem in node analysis. So marking voltage V1 means it is voltage which is dropping across R1, which is dropping across R1 means the positive polarity is with the node, the negative polarity is with the ground. Okay, so V3 means the positive polarity of V3 is with the node and the negative polarity is with the ground. So in the same manner, if I mark V2 here, V2 is dropping across this voltage source, which means that V2 is your 10 volts. Everybody get this point? Okay, so with this knowledge, let's move on to a problem. The third problem that we are solving. Okay, let's take this. This is the problem that we have to solve. Okay, now problem number 3. Everybody fast, you can make a note of this circuit, or if you don't want, you can just listen. You can take it down later on. Fine, just listen to now. Fine, this is the third problem in node analysis we are taking. Okay, which type problem is this? Is type 2 problem. Type 2 problem according to us in node analysis. Okay, the current source is available. In type 1, the current sources were not there. See here, the current sources were not there. The first problem that we took. Okay, we named it as no type 1, no current sources. Current source is there. Okay, so type 2, here also current source is there. Okay, so this is also type 2 problem. But here, how this problem is special from the other two problems we have seen. Something that didn't happen with the other two, that is happening here. First, how many nodes? How many nodes? When I say how many nodes, you're not counting this non-reference node. This is ground. You're not counting this. Okay, so you have to find out the points wherein the 3 branches are coming together. So this is 1, 2, 3. So this is one node. 1, 2, 3. This is one node. 1, 2, 3. So three branches are coming together at these points. So I can say these are our nodes. There are 3 nodes now. Everybody is okay with that? There are 3 nodes. What is that they have asked us to find out is this. Find the power delivered by everybody. They're asking us to find the power delivered by 1 ampere source. So we cannot stop here. We should say by which method. Otherwise, you can even do this problem of mesh analysis. So that's why you should always see which method they are talking about. So this has to be solved by node analysis. So find the power delivered by 1 ampere source by node analysis. So in node analysis, we have to find out first the node voltages. Next, we shall see what is asked. Okay, so first we have to find out the node voltages in node analysis. In mesh analysis, we have to find out the mesh currents, whether they are asked or not. In node analysis, we have to find out the node voltages. So as we were counting the number of meshes there, here we have to count the number of nodes. So, and we have to mark the node voltages. There we were marking node currents. Okay, sorry, mesh currents. Here we have to mark our node voltages. So let me mark this as voltage V1, okay, V2 and V3. Everybody understand that point? Let me tell you, these V1, V2, V3 were not marked earlier. So we have marked these voltages, mind you. You're not doing this otherwise. Let me just. Why I'm so particular about coloring is you should understand what is given, what is not given in the problem. See, what I'm doing now is something we have to do by ourselves. That means it is not there in the circuit. So since it is being asked to be solved by node analysis, we should know we have to mark the node voltages. So in the solution, you would first say mark the node voltages as shown. Everybody start now. In the solution, mark V1, V2 and V3 as shown. Okay, now by observation there is something that we can make out. Okay, the question that you need to be asking yourself is, do we know any voltages, any node voltages? As we used to ask, If there is a current source on the boundary, we know the mesh current. Likewise, if you have a voltage source in between the node and the ground, in between a node and the ground, okay, then we can say we know that particular node voltage. So since there is a 12 volt source between node 2 and ground, I know voltage at node 2. Since there is a source, voltage source between node 2 and ground, I know V2. Okay, so how to say that? It is just by observation we can say that. Okay, so by observation, what's happening by observation here? We can know that our V2 is plus 12 volts. So this is one finding just by observation. Okay, so how many KCL problem is this now? There are three nodes. I know one of the node voltages. So how many KCLs we are applying? We are just applying KCL at 1 and 3. We are not applying KCL at node 2. So in that sense, it is just a 2 KCL problem, though there are 3 nodes. Understand that? Okay. Now let's apply KCL at node 1. Before that, let's just have this discussion. Suppose this minus sign is at the top and plus sign is at the bottom. So then you should understand V2 is going to be negative, minus 12. When would V2 be minus 12? If this minus is connected with this node. Okay. If the minus polarity is there with this node, then V2 would become negative. If the plus polarity is there with node 2, it would become plus 12. Just that. Okay. So you have to just observe it properly. Now let's go with node 1. Okay, so applying KCL at node 1. Let's not say apply KCL at node 1. It's not KCL at V1, mind you. Most of the students, they write KCL at V1. V1 is the voltage, node voltage. We don't apply the KCL at voltage. We apply the KCL at node, mind you. Yeah. Now observe here how many branches coming at node 1. There are 3 branches. Branch number 1, 2 and 3. 3 branches are coming together. Now there are 3 currents. 3 branches means 3 currents. How many of them are entering? How many of them are leaving is the next question. So KCL says the sum of the currents entering is equal to sum of the currents leaving. So you should see here, in these 2 branches there are no current sources. Okay, that's why we assume that the currents here in these 2 branches are leaving node 1. So one current goes like this, another current comes like this. It is leaving node 1. Okay, but since this 1 ampere current source is showing the current entering the node 1, okay, it very clearly is understandable that this is a current entering node 1. So sum of the currents leaving would be equal to the sum of the currents entering. Okay, so how our KCL would look like? I'll just write here, then I'll take that equation down. Yeah, at V1 what we're doing is this. What is the current here that is flowing in this branch? So it's V1 by 4. Get that point? So it's V1 divided by 4 plus there is another leaving current. What is that? It's V1 minus V2. Let's write minus V2 first, then let's then we can substitute this plus 12 to V2. Okay, so while writing, let's write it as V1 minus V2 since we're all beginners. Just we have started, right? So let's all write it as this. Okay, so it's V1 minus V2 by 2 equal to, so sum of these 2 leaving currents is equal to entering current, that is 1. Everybody understand that? So this is how the KCL looks like. Yes, the challenge is what we have denominator here, so we need to bring it to the standard form. So how to bring it to the standard form is this: take the LCM and get going. Fine. Yeah, what is the LCM? Shall we take 4? Yeah, so if we take 4 as the LCM, so it would be 4V1 plus 2V1 minus 2V2 equal to 4. this further implies that it's a 6v1 minus 2v2 equal to 8. Okay. Further, what we can say, substituting v2 equal to
It's not 6v1.
how much? 6v1 minus this is how much? Oh, this is 4. Sorry. This is 1, right? Anyways, this is 1. So why did I do this? This is 1, right? So it would be 4. Yeah. So substituting V2 equal to 12 volts, what would happen? 6V1 equal to 4 plus how much it is? 12 to the 24. So it becomes 28. So what is our V1? V1 is 9.33 you're getting. Is V1 9.33? No. How much would it be? 6V1.
LCM is wrong, sir.
Huh? LCM is wrong.
Sir,
LCM is
you
how
did.
much?
Yes, sir. Sir, you did mistake in the second step, sir.
LCM.
Yes, sir. 4 only, no, 4 will not be there, only V1.
Yeah, this is V1. Exactly. So how much it would be? So it would be 3V1, right? Yeah, let me do that.
3V1 minus 2V2 is equal to 4.
Yeah, 3V1 minus 2V2 is equal to 4. So substituting V2, what do we get? It would be what? It would still be 3V1, right? Yeah. Now tell me the answer. 3, 6. Yeah, anybody with the answer there? Yeah, V1 would
volts.
be 9.33 volts. So now we know V2 and V1. Okay. So what we have to do further? What we have to do further? We have to go with node 3. We are not applying KCL at node 2 because we know the node voltage. So operate at node 3. And when we are operating at node 3, what is that you need to again look at? We have 3 currents because we have 3 branches. How many are entering? How many are leaving? The current which was entering node 1 is actually leaving node 3. So in that sense, anyways, we assume the currents as leaving currents here, and this anyways is a leaving current, that 1 ampere. So what would the KVL be? Sorry, KCL be at node 3. Write that yourselves. Write that KCL at node 3, everybody. KCL at node 3. So how does it look like? It looks like V2 by 3, sorry, V3 by 3, okay, plus V3 minus V2 by 2, okay. Then this 1 ampere is also leaving. In the previous case, it was entering node 1, but it is leaving node 3. I hope everybody understand that. Okay. So bring this to the standard form again. Bring this to the standard form. Yeah. Where did this go, my pointer? Yeah, this is it. Fine. Now, can you give me V3, everybody? Bring it to the standard form again. Let's take 6 as the LCM. Fine. So it's 2 times V3, 3 times V3 minus 3 times V2 plus 6. Okay, equal to 0. This 6 gets multiplied by 0 on the right hand side, so it vanishes. So how many you are having? So I'm having minus 3v2 yeah, It's minus 3v2. Okay. Then minus 3, yeah. Then plus 5v3 equal to minus 6. Okay. Substituting v2. Okay. Equal to what? What is that? We're substituting it as 12 volts. What do we find our V3 to be? Anybody with V3?
5,
Huh?
6,
Yeah, yeah.
6 volts.
Yeah, 6 volts. V3 is 6 volts. Okay. Now what you would do? So all the three voltages are there with us. See, V1 is there. V2 was anyways known from the circuit diagram, and V3 is known now. What is the question that they've asked? They've asked us to find out the power delivered by 1 ampere source. So what they're asking us is, everybody look at this. It's power delivered by 1 volt source. Anyways, it is V into I. Anyways, it is V into I. Okay. We know the current. We know the current, that is 1 amp. Do we know the voltage? No, we don't know the voltage. So mark this voltage. Mark. Okay. Mark as shown. How it is going to be marked? Anybody? How we mark V? See, we mark V like this. Our V should be marked in such a way that its positive sign would be with the arrowhead. So this is our V. So do we know V, anybody? I have marked V there. Do we know V? Anybody there? Do we know voltage V that we have marked across this 1 amp? Why did we mark this voltage V? Because 1 ampere source is known. Okay, I need to know the voltage across that. That I don't know. So I have to mark that, and we have to find what is the voltage across this is. What is the voltage? See, this V plus sign is with V1 and minus sign is with V3. See everybody, just observe. Okay, so this is V1 means this also is V1, this is V3 means this also is V3. So it is plus V1 minus V3. Everybody understand? So your V is plus V1 minus V3. Okay with that? So this is what we need to do regarding V. Okay, when we are asked to find out the power delivered by the current source. Okay, so this is how it is going to be, everybody. So we have marked V. Okay, and what is V? We know that V is given by what? V is equal to V1 minus V3. So this implies that our power delivered by, is it 1 volt? No, yeah, it's 1 ampere. Sorry, huh? It's 1 ampere. So why did I write 1 volt? Yeah, let me correct that. So it's power delivered by 1 ampere source. Fine. So it's V is V1 minus V3. Okay. So this implies that our P delivered by 1 ampere is V1 minus V3. Okay, into the current 1 ohm. So therefore, what is V1? V1 is 9.33 and our V3 is 6 volts. Therefore, power delivered by 1 ampere source is 3.33 watts. Everybody understand this point? So how to find out the power is something that we have to learn. This is very similar to what we have done, but this is the first time we have come across this. How to find out the voltage that we have marked in node analysis. It's quite simple stuff. So this is plus V1, this is minus V3. So plus V1 minus V3 is actually your V that is dropping across the current source. Is this okay with you, everybody? Fine. Now let's move on with another problem. Okay, let's see this. Everybody just see. You need not have to copy. You can copy the problem later on. Okay, or if you're fast, you can very fast, you can copy this. Anyways, the video is going to be there with you. Okay, so let's not bother much. You can copy it fast. If you're not able to copy, you should not miss the explanation. Okay, this is the fourth problem. Okay, what type of problem can you tell me here? Anybody? What type of problem is this in node analysis? See here, when we discuss node analysis, okay, we discuss the this is when there is no current source. This is how the things look like. When there is a current source, this is how the things look like. Okay, when there is a voltage source between the two nodes, okay, then it's a super node analysis. Okay, so is there a voltage source between the two nodes? Anybody? First, let me tell you, let me just give how many nodes are there. First, how many nodes are? What you're supposed to be finding is voltage VA. Where is that voltage VA is given? So here is voltage VA. So plus minus. Find what they're asking is this. Find VA by node analysis. First, read the circuit and try understand what type of problem is this. How many nodes? Okay, there are three nodes. Okay, there are three nodes. I'll mark the node voltages. This is V1, V2, and V3. Very similar to the previous problem. Again, this V2 is known because there is a voltage source between node 2 and there is a voltage source between node 2 and ground. So I know V2. And along with that, there is a voltage source between the two nodes. Okay, if there is a voltage source between the two nodes, what we used to do? See here, if there is a voltage source between the two nodes, we need to form a supernode. Supernode is what? Supernode is combining two nodes between which you find a voltage source. So that case is here. If it's a voltage source between V1 and V2, then also we have to form a supernode. Then we will combine this. If there is a voltage source between second and third node somewhere here, then we form a supernode like this. But since there is a voltage source between 1 and 3, now we have to combine 1 and 3 to form the supernode. Is everybody okay with this? It's a supernode problem. So how to combine? Everybody just look at this. How to combine? See. So I'm combining node here. I'll just shade it so that you can understand better. So whatever the shaded area you're saying, right? So that is one node now. That is one node. If you take node 1, there are 3 branches. 1, 2, 3. If you take node 2, again there are 3. If you take node 3, there are 3 branches. But if you take the super node, how many branches are there with the super node? So this is 1, 2, 3, 4. There are 4 branches. How many nodes together would form a super node? 2 nodes together would form a super node. Like 2 meshes together would form a super mesh, right? Okay. Similarly, 2 nodes together would form a super node. How many KCL problem is this? How many KCL problem is this? Okay. There are 3 nodes. We know this node voltage, and since there is a super node between 1 and 3, it's just one KCL problem. We'll be applying KCL only to what? The super node. One KCL to the super node. Okay. So how many unknowns are there? How many unknowns are there? Anybody? V1 and V3 are the unknowns. One KCL, 2 unknowns, not sufficient. So when it is super mesh problem, we used to write the constraint equation, right? Similarly, when it's a super node problem, another equation is found by the constraint equation. Okay. Everybody just make a note here in the solution. Form the super node between, everybody make that statement, combine node 1 and 2. Combine node 1 and 2. Combine nodes 1 and 3 rather. 1 and 3 to form a supernode. Form a supernode. Why we are combining them? Since there is a voltage source in between. Since there is a voltage source in between node 1 and 3, we are forming a supernode as shown. Understand? To form a supernode as shown, you say here. As shown. Okay. So now before that we have to say mark V1, V2, V3. Okay. The first thing that we have to do, since we know one of the node voltages, which node voltage we know? V2 we know, right? So let's say, okay, by observation, what do we know? By observation, what do we know is this? What is that? V2 is 12 volts. So this is known by just by observation. Okay. Then it's a supernode problem. Since it's a supernode problem, I need to write the constraint equation. Everybody just look at this constraint equation. If it's a super mesh problem or supernode problem, we have to write the constraint equation. Now, what you have to do is you have this 8 volts, right? Can we write these 8 volts in terms of the node voltages is the question. Anybody? Can we write, how can we write this 8 volts in terms of the node voltages?
Sir,
V1 minus V3 is equal to
Yeah, it's V1 minus V3 because V1 is connected with the positive, V3 is connected with the negative. So V1 minus V3 would give you 8 volts. So that is your constraint equation. If you don't write constraint equation, the number of equations would not be sufficient. So it's V1 minus V3 equal to 8 volts. So this is one equation you can call. Now we are just having one equation, but there are how many unknowns? 2 unknowns are there. We need another equation. From where another equation we can get? We can get another equation by applying KCL to supernode. Everybody understand that? So let's write KCL to supernode here. KCL to supernode. How many branches? Let me explain you that. If you have not given your attendance, please give attendance now itself. Yeah. How many branches here? 1, 2, 2 branches are going to node 1 and these 2 branches are going to node 3, but we cannot say node 1 and node 3. Now node 1 and node 3 together is called as supernode. So you can just say that. So this is super node. Okay, so it is, we should not talk in terms of node 1 and node 3, we should talk in terms of supernode. Okay, so 4 branches, 4 currents, and all the 4 currents are leaving. All the 4 currents are leaving. So which are those currents? Which is this current? It is V1 by 500, V1 minus V2 by 125, V3. We should not say V2. V2 is not the part of supernode, mind you, and we are not applying KCL at 2 also. So that's quite a thing that we've learned. So it's V3 minus V2 by 250, V3 by 500. So this is how the things go. Okay, so it's V1 by 500, one current leaving node 1. There is another current leaving node 1, that is V1 minus V2 by 125, okay, plus V3 by 500 plus V3 minus V2 by 250 equal to 0. Since there are no entering currents, this is equal to 0. Everybody understand what is this V1 by 500? So this is V1 by 500. This is V1 minus V2 by 125. Again, we have to come here. It's V3 minus V2 by 250, V3 by 500. This is how our KCL looks like. I hope everybody understands. If you have not understood, you can just unmute and you can talk to me. Okay, we're left with 5 minutes. I'm trying to rush through within that. Yeah. Now bring it to the standard form. What is that? 500 is the LCM. 500 is the LCM. Okay, so it's a v1 plus 4v1 minus 4v2, okay, plus v3 plus 2v3 minus 2v2 equal to 0. Okay, so this 500 vanishes because this gets multiplied by 0. Okay, substitute v2. What is v2? Substitute v2 equal to 8 volts, sorry, 12 volts. V2 is 12 volts. So how many V1s there? 5. Okay, 5 V1, 5 V1. How many V2s? Minus 6 V2 plus 3 V3. Correct me if I am wrong. Okay. Substituting V2 equal to 12, what happened? 12, 6 is 72. 72 comes on the right hand side. So what would happen? Implies 5v1 plus 3v3 equal to 72. Is this fine with you, everybody? This is your second equation. Okay, solve equation 1 and 2. Solve equation 1 and 2 for v1 and v3. Anybody with v1 and v3 there? Anybody with v1 and v3? Okay, v1 we are getting to be, okay, solving
12 and 4.
12 and 4. Good. Solving 1 and 2, you have to know to use your calculators. Okay, so v1 is 12 volts. Something happened. v1 is 12 volts, and v3 is 4 volts. Write that, everybody. There are some problems. Everybody just write down that. v1 is 12 and v3 is 4, and they've asked us to write, what? VA. And what is VA, everybody? VA is what? VA is V3. So you can write your V3. So VA is equal to V3 is equal to 4 volts. Okay, so you can do that. Everybody do that. VA is equal to V3. Okay, and that is equal to 4 volts. Yeah, solving this equations 1, that is the constant equation, and the equation that we have got by applying KCL to the supernode. The equation number 2, the unknowns here are 2, that is V1 and V3. So you have two equations 1 and 2. So solving them, we have got our V1 to be 12 volts and V3 to be 4 volts. Now what is that they have asked is, by mesh analysis they have asked, by node analysis they have asked us to find out node voltage, sorry, VA. So the VA is here, and this VA is equal to what? VA is equal to V3. As I was telling you earlier, if I mark a voltage here, okay, it's as good as the voltage that is dropping across this branch. So similarly, if we mark a voltage V3 here, that V3 is the voltage that is dropping across this particular branch, means the resistor in that branch. So V is also the same voltage. So VA is equal to V3, and that is how VA can be written as 4 volts. I hope you have